Example 4. You buy a tall three-legged plant stand. When you place a plant on the stand appears to be unstable under the weight of the plant. The diagram shows a coordinate plane superimposed on one pair of the plant stand's legs. The legs are extended to form triangle OBC. Prove that triangle OBC is a scalene triangle, and then explain why the plant stand may be unstable. So, first of all, if it's a scalene triangle, that means all sides are different lengths. So we have to prove that all sides of this triangle, when you extend the legs up to point B, have different lengths. So in order to do that, we're going to use the distance formula and some counting. So the first leg I'm going to find is the bottom one, which is from O to C. And that one's not too hard because OC, you just have to count. So it looks like they're counting by 4s or maybe 6s. So this is 6, 12, 18. So the distance between 0 and 18, we know that OC has a length of 18 units. Now the next one I'm going to find is the distance between O and B. Now in order to do that, we can use the distance formula, but once again, I'm just going to make a right triangle. Drop it down, drop it over. I know that the bottom distance here of the green one is going to be 12, and from the bottom up to point B, it looks like we went a total of 48. And we're going to try to find this side over here from O to B. So from O to B, we're going to have 12 squared plus 48 squared equals OB squared. Now, if we simplify that, we know that 12 squared is 144, plus 48 squared is 2,304. Then we're going to add those together, which is 2,448. And then in order to get rid of r squared, we're going to take the square root of both sides, which gets us, if we simplify, if we leave it as a decimal, we can get 12 root 17. But if we go with a decimal, OB is approximately 49.477. Okay, so far we're trying to prove it's scalene, which means all side lengths have to be different. So far we're doing a pretty good job because the first one is 18 and the second one is roughly 49. So the last side length we have to find is from B to C. I'm going to do the same idea. I'm going to drop this down. I'm going to drop that over, make a right triangle. Here I'm at 12 over to 18, so I know this is 6. And then the whole way up, this is still 48. So in order to find BC, we're going to do 6 squared plus 48 squared is equal to BC squared. That's going to give us 36 plus 48 squared, which is 2,304, equals BC squared. Then we're going to add those together, which is 2,340. And then in order to get rid of the squared, we're going to square root. And already you can see that these are not going to be equal, because over here we're sitting with the square root of 2,340, and over here we're sitting with the square root of 2,448. So those are not going to come out to be the same. But if we do it, BC is approximately 48.374. So by looking at that, we can conclude, because none of the sides are equal in length, that yes, it is scalene. Check. Now, the last part said, explain why the plant stand may be unstable. Well, the reason is because it is in fact scalene. If you were going to construct a plant stand that you wanted to be stable, I would imagine that you would want it more centered. So instead of having your plant stand sit here, you'd almost want that center point over here so that you had the same distance on both sides, which means if you wanted this to be stable, what you would really want is, instead of a scalene triangle, you would want an isosceles triangle so that the weight distribution was centered in the middle.